Functions extra sums video 2. Supposing there's a function f of x is equal to 9x square plus 6x minus 5. To prove it's one to one and onto, what you should do is, as usual, you should assume this to be f of x1 to be equal to f of x2. So 9x1 square plus 6x1 minus 5 is equal to 9x2 square plus 6x2 minus 5. The 5 and 5 get cancelled. Consolidating, 9 into x1 square minus x2 square is equal to 6 into x2 minus x1. So then this is 9 into x1 plus x2 into x1 minus x2 is equal to 6 into x2 minus x1. So I'm going to take it that side. 9 into x1 plus x2 to x1 minus x2 minus 6 into x1 minus x2 is equal to 0. When I take it that side, it will become negative. Switching it, x1 minus x2 can be taken out common. 9 into x1 plus x2 minus 6 is equal to 0. So then can we see this question, what you have to read is in the function, its real positive is turning to minus 5 to infinity. So the domain is real positive numbers. Real positive numbers means definitely this can never be equal to 0 because they are real positive numbers. Addition of two positive numbers will never be equal to 0. So therefore you can justify that this can be 0. So x1 minus x2 is equal to 0, x1 is equal to x2. You have to write that. Since x1 and x2 belong to real positive numbers, addition of two real positive number can never be 0, and therefore this will never be 0, and therefore x1 minus x2 is equal to 0, x1 is equal to x2. It's very, very important. That confirms that it's 1 to 1. And to prove it's onto, how to prove it's onto? I've told you the condition for onto is either f of x is equal to y or f inverse of y is equal to x is the condition for onto. For which you can prove one of this. Just proving this is enough. What is x stands for? You know this itself is y. So y is equal to 9x square plus 6x minus 5, and you have to find what is x from here. You are not able to club x and take it out. While you do that normally, not able to consolidate x. So you have to do completion of square, 3x the whole square plus 2 into 3x. So this is like a square plus 2a, then b is 1 obviously, plus 1 minus 5, because in order to have a b square I have to include a plus 1, and I can't randomly add a 1, I should subtract a 1 and bring the minus 5 here. So this becomes a 3x plus 1 the whole square minus 6. And so the 3x plus 1 the whole square is equal to y plus 6. 3x plus 1 is equal to root of y plus 6. And 3x is equal to root of y plus 6 minus 1. And x is equal to root of y plus 6 minus 1 by 3. And this is what is your x. And you should substitute that in here, because you have to prove f of x is equal to y. So f of root of y plus 6 minus 1 by 3. And wherever x is, you have to substitute this. And what is the formula for it? It's 9x square plus 6x minus 5. 9x square plus 6x minus 5. Wherever x is, you should substitute it. 9 into root of y plus 6 minus 1 by 3 the whole square plus 6 into root of y plus 6 minus 1 by 3 minus 5. This and this get cancelled. This is also 9. 3 square will become 9 and 9 get cancelled. You have to do a minus b the whole square. A square plus b square minus 2ab plus 2 into root of y plus 6 minus 2, taking it inside, minus 5. This and this get cancelled. This is minus 7 and plus 7 get cancelled. Answer itself is turning out to be y, and that's what you need to prove. To prove that f of x is equal to y. That's the whole point. Okay, this is a very, very important one-to-one and onto relationship that you have to prove. But if the same question was with real numbers and not real positive, then you can never justify, because this can become 0 in that case. So we can't be surely saying that this will not be equal to, this will become 0, you know. Unless you justify, either one the 0 ஆகாது நாதா இது 0 ஆகும். And the justification is very important. So and that is a very important question. So the next question is the second question of this video, which is show that f of x is equal to 4x by 3x plus 4 where it's defined by, obviously denominator cannot be 0, x cannot be minus 4 by 3. So for all domain which is real number other than minus 4 by 3 is related to the entire real numbers, be a function defined as like this. Check if this is 1 to 1 or onto. So when they give you like that, it is all real number. When x is 1, obviously when x is 1, it will be 4 by 3 plus 1, which is 7. When x is 1, it's 4 by 7. When x is 2, then it's 8. 3, 2 is 6, 6 plus 4 is 10. So it's 8 by 4, which is 4 by 5. And so then like that, what about when x can also be a fraction? X can also get to be a fraction. So supposing it is 4 by 5, x itself is 4 by 5 or 5 by 4. The 4 and 4 get cancelled. 3 into 5 by 4 plus 1 will be 5 by 15 by 4 plus 4, which will be 5 by 16 plus 15, which is 31 and 4, so it's 20. It's all of them seems to be like a fraction. Can you see? So then therefore, okay, 1 second, hold on. So let me, where is the mic? Okay, so then to prove that it's 1 to 1 and onto, you just have to generally do it the way you've been doing, because it's a complex function, so don't think of it as numerical. Whenever it gets to, don't define the domain and range like that, just do it simply. F of x1 is equal to f of x2. 4x1 by 3x1 plus 4 is equal to 4x2 by 3x2 plus 4. So cross multiplying 12x1 x2 plus 16x1 is equal to 12x1 x2 plus 16x2. This and this get cancelled. 16 into x1 is equal to 16 into x2. 16 get cancelled. x1 is equal to x2 shows that it's 1 to 1. And to prove it's onto, you have to prove either f of x is equal to y or f inverse of y is equal to x. Inverse is not there in the portion, so f of x is equal to y, where what is x? Y is equal to 4x by 3x plus 4, and cross multiplying, so you get a 3xy plus 4y is equal to 4x. So x into 3y minus 4 is equal to minus 4y. X is equal to 4 by y, 4 minus 3y. So take it and substitute it here. F of 4 minus 3y. Wherever x is, you should write that. So it's 4x by 3x plus 4 is the function. Wherever x is, you're going to write this 4y by 4 minus 3y by 3 into 4y by 4 minus 3y plus 4. So we take LCM, 16y by 4 3 is 12y plus 16 minus 12y, this and this get cancelled, 16 get cancelled, so f of x is equal to y shows that it's also onto. Thus you prove that's 1 to 1 as well as onto. Let's go to next question. So let's go to third question of the day. F of x is equal to x by x square plus 1, where a function is real numbers trending from real number to real number. You have to prove that it's neither 1 to 1 nor onto. It's neither 1 to 1 nor onto is what you're going to prove. So when it's neither 1 to 1 nor onto, how do we prove that? Okay. So generally, this is a quadratic function, so negatives will also become positive. Okay, so then, okay, let's do it another way, which is like f of x1 is equal to f of x2. x1 by x1 square plus 1 is equal to x2 by x2 square plus 1. So cross multiplying x1 x2 square plus x1 is equal to x1 square x2 plus x2. So consolidating this and this, you'll get x1 x2 can be taken out common. You get x2 minus x1 is equal to x2 minus x1. You're going to take it that side, correct? And so you're going to take it to one side, x1 x2, x2 minus x1 minus of x2 minus x1 is equal to 0. So then if you take x2 minus x1 out, you'll get x1 x2 minus 1 is equal to 0. Look at this question. This is from real number to real number. So then these two are real numbers. Okay, and to prove it's 1 to 1, you should be able to prove that this is definitely not equal to 0. Only then you can prove that this is equal to 0. Okay, that's where the challenge is. So can you see the multiplication of two real numbers? The multiplication of two real numbers can become, this can be lead to 1, this can 2 into 1 by 2 can be 1, and this can become 0. Therefore I am not able to justify that x1 can be equal to x2. I am not able to justify, unable to justify, and therefore you have to say it's not 1 to 1. Okay, so two real numbers products minus 1 can lead to 0. Or in other words, you can also say, yeah, that's what it is. So then therefore you can say that it's definitely not 1 to 1. What about onto? To prove it's onto, what would you do? You write y is equal to x by x square plus 1. And you generally cross multiply y x square plus y is equal to x. To consolidate x, so y x square minus x is equal to minus y. And you should be able to consolidate x, and you're not even able to consolidate x from here. So generally in that case we will do completion of square, which is exactly what I did in the previous sum. Like here, or to find onto, I was doing completion of square. So then let me think. So I'm trying to do the same method, doing completion of square. That's not going to work. Okay, since you are not able to segregate x. Okay, so then you can say that it's not possible to check onto, therefore it's not onto. Not onto. Okay, so then therefore this is the question where it's x by x square plus 1. Real simple method, if you want to say, if you take minus 2, it will become what? A minus 2 by a 4 plus 1, which will be minus 2 by 5. So minus 2 is getting mapped to minus 2 by 5. A plus 2, if you map it, it will be 4 plus 1 will be 2 by 5. It appears to be 1 to 1. Can you see? When you do it numerically, so you can't do it numerically here. You just have to because the question itself is to prove that it's definitely not 1 to 1. It's neither 1 to 1. That's what they are asking you to prove. So then therefore you write it's not 1 to 1. It will be many to 1, and it will, yeah, quite a weird sum, right? X by x square plus 1 for, you have to do it only theoretically to prove that it is not 1 to 1. Okay, and so do it like this and prove that's not 1 to 1, and what else to say? And you cannot segregate x from here, and it's not a numerical for you to do completion of square and get it, and so therefore it's not onto.